Here we'll solve few questions from the friction topic. So first question is a 400 Newton block is resting on a rough horizontal plane for which the value of coefficient of friction, that is mu, is 0.40. Determine the force required to cause motion to impede if applied to the block horizontally. So it's given that I'll solve this. It's given that a 400 Newton block is resting on a rough horizontal plane. So I'll draw the figure. Suppose this is the horizontal plane and a 400 Newton block is resting over it. So weight of this block is 400 Newton. And next it is given that the value of coefficient of friction is 0.40, that is mu equal to 0.40. So we know that from the Coulomb's law, limiting friction is mu times normal, F limit equal to mu times normal reaction. That implies mu is 0.4 times normal reaction. So we have to calculate the normal reaction. So here it is given that the block is resting horizontally on this surface and weight of this block is 400 Newton. So weight is pulling this body downward. So the block is resting on this horizontal surface. So the surface will provide a contact reaction at this point, so which will balance the weight, otherwise it will go inside this ground, inside the surface. So to balance it, the surface will provide an reactive force which will balance the weight. So what will be the reactive force? So we'll balance the vertical force. So R equal to, so we'll balance the vertical force. So R equal to weight, that is 400 Newton. So what is the value of limiting friction? F limit equal to 0.4 into 400, that is equal to 160 Newton. So this is the maximum value of frictional force. So the frictional force limit is 160 Newton. So we know that the body will only move when the applied force is greater than this limiting frictional force, because the work of friction is to retard the motion. It will try to oppose the motion. So to overcome this, we have to apply a force greater than or equal to frictional force. So this force which is required to overcome this equal to minimum value of force required to impede the motion equal to the limiting frictional force, that is 160 Newton. So I hope you all are clear. So we'll solve the second question. The second question is a body of weight 400 Newton is lying on a rough horizontal plane having mu equal to 0.3. So here this is the horizontal plane and the body of weight 400 Newton is resting over it, and it is given that the coefficient of friction between the contact surface is 0.3, that is mu equal to 0.3. Find the magnitude of force which can move the body while acting at an angle 25 degree to the horizontal. So we have to find out the force which will be required to move the body when here the force is acting at an angle 25 degree to this horizontal plane. So here the force will have two components. So as the force is inclined, so we'll resolve the force horizontally and vertically. So the horizontal component is cos component, so P cos 25 degree, and the vertical component is the sine component, that is P sine 25 degree. So in this case, because of this contact between this surface and the body, it will provide a contact reaction, that is a normal reaction which will act normal to the surface. So these are all vertical force, and here the frictional force as this horizontal component is pulling this body. So the frictional force will try to oppose this. So we have calculated this we have drawn the free body diagram. Now you can see the horizontal and vertical forces. So we will balance the force. So we will balance the vertical force. So we are weight is acting downward and other two forces are acting upward. So vertical force, downward force will be balanced by the upward force. So R plus P sin 25 degree. P sin 25 equal to 400. 400 equal to R plus P sin 25 degree. Similarly, we will balance the horizontal force. So P cos 25 degree equal to frictional force. And from the laws of friction, that is from the Coulomb's law, we know that frictional force equal to mu times normal reaction. So from this we can relate this value with, we'll take this value to this side. So we'll get R equal to 400 minus P sin 25. So we'll put it here. So frictional force equal to mu times 400 minus P sin 25 degree. And from balancing the horizontal component, we have found that frictional force equal to P cos 25. So we have that value equal to P cos 25. That implies P cos 25 equal to mu value is 0.3 into 400 minus P sin 25. So we'll balance this value and we'll find the value of P after solving this equation. So I have solved this equation and I found that the P value is 116.529 Newton. So here 116.529 Newton force is required to start the motion when it is inclined at an angle 25 degree to the horizontal plane. So I think you all are clear from this, and we'll move to another question. So third question is about a body resting on a rough horizontal plane required a pull of 180 Newton inclined at 30 degree to the plane just to move it. So first it is given that a body is lying on a rough horizontal plane, required a pull force. So it's pulling the body, that means it's away from the body. Pull force of 180 Newton inclined at 30 degree to the horizontal plane just to move it. It was found that a push type force, another same body lying on the same surface, and push type force. So it will, push type means it will compress the body. So its sign will be, vector head will be towards the body. So its magnitude is 220 Newton. Pull type means tensile force. Its away, vector head will be away from the body, and push type means compressive force. So its vector head will be towards the body. So its magnitude is 220 Newton and it is also acting at 30 degree to the horizontal. So it is asked to determine the weight of the body and coefficient of friction. So here the body is same, so weight of the body will be same, W, and both are lying on the same surface. So coefficient of friction depends on the contact surface. So as the contact surface is same for both the case, so mu value is also same. So here also coefficient of friction between the body and the surface is mu, and it is applied a pull type force, and here it is a push type force, and both the force are required to move the body when the, so here here also the contact surface there will be a normal reaction, and here also there will be a normal reaction, but the normal reaction value will be different as the applied force is different for two cases. So here let the normal reaction is R1 and here let the normal reaction is R2. So we'll now resolve these forces. So its horizontal component is 180 cos 30 and its vertical component is 180 sin 30. Similarly, its horizontal component is 220 cos 30, but its direction will be towards the body, and it's also if we'll resolve this, it will be also downward. It's a compressive nature, so here it will be towards the body. So its vertical component is 220 sine 30. And as the normal reaction is different for two cases, so frictional force will be also different. So here frictional force is Ff1 let, and here let frictional force is Ff2. So we, for case 1 and case 2, we'll write separate equations. We'll balance the horizontal and vertical forces. So for case 1, let first balance the horizontal forces. So for case 1, R1 plus 180 sine 30 equal to W. So for case 1, R1 plus 180 sine 30 equal to W, and Ff1 equal to, balancing the horizontal force, 180 cos 30. Here from the Coulomb's law, Ff1 equal to mu R1, that is equal to mu into R1 is, we'll take it that side, so W minus 180 sine 30. So that implies 180 cos 30 equal to mu times W minus 180 sine 30. From here we got this equation. Let this is equation 1, and we'll similarly solve for case 2. We'll balance horizontal and vertical forces. So here R2, here weight is downward and this 220 sine 30 is downward, so this will be act in one direction and this is in opposite direction. So this reaction will balance these two forces. So R2 equal to W plus 220 sine 30, and frictional force 2. Here the force is acting in this direction, so frictional force will be in opposite direction. I'm sorry, that direction will be like this, because frictional force always acts in the direction opposite to the applied force. So here the applied force is acting towards the body, so friction, this will try to move the body in this direction, so frictional force will act in opposite direction, so in this direction. So we will balance the horizontal force. So frictional force will equal to 220 cos 30. So now in the same way, frictional force equal to mu times normal reaction. Here normal reaction is R2, so mu times R2 is W plus 220 sine 30, and this frictional force value equal to 220 cos 30. So we'll equate this, and let this is equation 2. So we got two equation, and there are two unknowns, so we can easily solve this. Two unknowns are mu and W, which we have to calculate. So for two equation and two unknown, so we can solve it. So let's solve this. So we'll divide equation 1 by equation 2. So let's divide 180 cos 30 divided by 220 cos 30 equal to mu into W minus 180 sine 30 divided by mu into W plus 220 sine 30. So mu is same, so mu got cancelled. So what is 180 cos 30 and 220 cos 30 will get cancelled. So 180 divided by 220 equal to W minus 180 sine 30 is half, that means W minus 90 divided by W plus 220 sine 30 means 220 by 2, 110. So here we'll solve this equation. So 180 by 220 equal to W minus 90 divided by W plus 110. We'll multiply this side and this side. So we solve this equation, and we got the W value is 990 Newton. So we'll put the value of W in one of the equation to calculate the value of mu. So I put it in the first equation. So 180 cos 30 equal to mu into W minus 90, that is 180 sine 30. So after solving this, I found the value of mu is 0.1732. So I think now we can solve all the problem related to friction. The problem related to horizontal plane. If the body is lying on a horizontal plane and the force, any kind of force like horizontal or inclined, now you can calculate it applying Coulomb's law, and you can balance the horizontal vertical force, and you can apply Coulomb's law and solve any value asked in the question.